Good afternoon, everybody, and thank you for joining me. Just a bit of an introduction. My name is Mark Oliver. I'm a business manager. I work for a construction company called Balfour Beatty Asset and Technology Solutions. And over the next 25-30 minutes, I'm hoping to inspire some of you guys on this call to become scientists, engineers, and get into construction and lots of exciting stuff like that. But before I do that, I just wanted to give you a very sort of whistle-stop tour, a little bit about me. So I've always had a real keen interest in engineering, even going back as a young boy. I guess I was first inspired by my grandfather. He, for Christmas, made me a box of gadgets, I suppose, comprising of wires, batteries, electrical switches, light bulbs and buzzers. And all it did really was made lots of noises and sounds, and I could switch things on and off. But at the age of 8, I think I was at the time, that was really cool for me. And I guess that was the moment that sort of set me on my path of having a real avid interest in engineering. And from then on, my parents were always moaning at me that my bedroom was full of sort of old radios, televisions that I used to take to bits. But it was a great way of learning. And by the age of 10, I'd made my own radio called a little crystal set. Now, a crystal set, you don't hear of them or see of them this day and age. But if you Google what a crystal set is, it's quite clever because it allows you to listen to the radio and it doesn't require any power whatsoever. And at the age of 10, that really inspired me. So that set me on to bigger and better things, having made my own radio at 10 years old. It used to drive my mum and dad mad because in order to get that radio working, you had to have a huge aerial, which in those days was in my parents' back garden. And it was like an aerial 100 meters long, which they weren't very impressed about. But I managed to convince them it was a good idea. I'm not quite sure how, but I did. But the rest is history, as you could say. Moving on from that, my qualifications. So I studied basically science and maths subjects at school. That's what took me into engineering from an educational point of view. I wasn't that great at maths. There's a bit of a myth that to go into engineering and science, you have to be really, really good at maths. It does help. But I actually failed my O-level maths the first time and I had to retake it. I did get it the second time. But I've basically got O-levels that they were. Now, you guys won't know what O-levels are. They're the equivalent to GCSEs now. I've got 6 of those, or possibly 7, but they're in sort of maths, physics, computer science, technology sort of discipline areas. So I got my O-levels. Then I went into A-levels, and I got 3 A-levels. Again, I did physics, technology, computer science, all sort of techie, engineering related, and I really enjoyed that. I had a final year project at in my A-levels where I had to make something which was really good. That was really, really up my street. That's something that I really enjoyed, and I got quite a good mark for that. Then I went to university. I went to Cardiff University and studied for a degree in electronic engineering. I did 4 years at Cardiff, really enjoyed it there. Lovely place, lovely city, lots of friendly people. And I came out with a Bachelor of Engineering degree, got a 2-1 in that. Then I went into work and started working for various companies. And my latest qualification is what you call a chartership. So I am a chartered engineer with the Institution of Engineering and Technology. And it allows me to put the word CEng after my name. A chartered engineer basically tells people you've got to a certain level in your career, a certain responsibility, and you've got so many years experience behind you. It's quite a well-recognised qualification to have. So I've worked for Balfour Beatty for 25 years. So I guess you could say I must like working for the company. Yeah, they're a cool company to work for. I first started working with trains, really, Balfour Beatty on the rail system. So I worked on machines that basically had computers on and sensitive electronic equipment. And the idea was for these machines to go out at night and fix the track to remove what you call track geometry defects, to allow the high-speed trains to run across the rail at 100, 120 miles an hour without derailing. So I did that for a while. That was really interesting. Then I moved into the area of innovation and development, or research and development, and started looking at little camera systems that we would put into water pipes to detect water leaks. In the water industry, there's a huge drive to reduce the amount of water that is leaking from water pipes. So we developed these cameras to detect those sort of situations. Then I worked in something called asset management. That was quite cool. That was working with offshore wind farms. So if you go off the North Sea coast, you'll see a lot of offshore wind farms and wind turbines. So I was involved with managing the high voltage transformers and the underground subsea cables for that. Then finally, I moved to what I'm doing now, which is called business management. So it's still a little bit of engineering. It's not quite as much engineering as I used to do. It's more about looking at innovation and how we can introduce new ideas and new approaches. And it's also about managing and working with people as well. So it's a lot more rounded type of work that I do now. But nevertheless, it's still very interesting. And I love what I do. So Balfour Beatty, you may have heard of what we do. We are one of the biggest UK construction companies in the United Kingdom. We also work in Hong Kong and the United States. And basically, in a nutshell, Balfour Beatty, they build stuff, whether that's roads, railways, buildings, bridges, tunnels, nuclear power stations, or overhead lines. And the pylons that you see running up and down the countryside, we've built a lot of those. So we built the Olympic Stadium back in 2012 in London. That's always a big one. Our biggest project on at the moment is High Speed 2 or HS2. For those of you, if you live in the Birmingham area, you've probably seen a lot of the construction works. Well, that's a lot of it is to do with Balfour Beatty. So we do a lot of building stuff up and down the country and across many continents as well. So some of the projects that we've been working on, I just thought I'd share with you. As engineers, we love to solve problems. It's what we're good at, it's what we do best. So I thought I'd talk to you about some of the problems we've had and where we've introduced innovation and new technology in to solve those problems. The first one is around potholes. Now, I'm sure you're all familiar with potholes. They are up and down the UK. You can't drive on a road for more than about 5 minutes without finding a pothole. Some of them are really big, some of them are quite small, but nevertheless, they're very damaging to cars, cycles, motorcycles, and the problem seems to be getting worse. So we came up with a solution where we worked with JCB to develop what we call the Pothole Pro. And that actually carries out the fixing of potholes on roads, as you can see in that photograph. And it uses a specially adapted bucket, which allows people to be away from the repair area. So at Balfour Beatty, we have a huge drive, something called zero harm, where we don't want to harm anyone, whether that's members of the public, whether it's the people that are working for us, or whether it's third parties. That is our number one goal. We need to operate safely. If we can't operate safely, then we might as well pack our bags and go home. So safety is absolutely paramount to us. So the idea of getting rid of the people from where the work was being done, i.e. where they would use manual techniques to repair holes, was a really attractive idea. So this machine does exactly that. It provides improved repair technologies and techniques. It provides many environmental benefits, and it reduces the time to fix potholes whilst delivering a safer means of repair. And that's, as you can imagine, it's in quite high demand, that machine up and down the UK. Another project where we've introduced innovation is a project called ElectLink. So the problem here is we had to install 52 kilometres of very high voltage cable, 400,000 volt cable, through the Eurotunnel. You're probably aware of the Eurotunnel. This is a tunnel that goes under the English Channel and it links England to France. So what we were tasked with, we had to install this cable into the existing tunnel. The problem we got is not only was it a technically difficult problem, we could only go in on a Saturday night between midnight and 6 o'clock when the trains weren't running, basically. And we had to design bespoke, quite unique equipment that you can't just buy off the shelf that would allow us to install this equipment onto the tunnel walls. So we designed what we call a monorail beam, which carried the cable, and we had a number of sets of trains that would go in during this possession period between midnight and 6 o'clock, and it would install these drilling rigs, and the drilling rigs would drill into the side of the tunnel walls where we would fix the brackets, which we would suspend the cable from. So it's a really exciting project, really interesting project. It lasted for a number of years, but we used robots to. You're probably aware robots are very, very good. They're very, very repeatable. They will drill a hole in exactly the same position, whether it's for one time or 1,001 times. And robots allowed us to give us that capability of repeatedly drilling holes in the tunnel walls. Another area of the business that we get involved with, we have to install huge tons, or 50,000 tons worth of cable, electrical cable, high voltage cable. A lot of this cable goes in underground. The problem is, as you can see from that photograph, that those cable drums are huge. They're 50,000 kilograms, so they're very, very big. So how do you actually get one of those big cable drums to the point out in the middle of nowhere where you have to install the cable? And the solution that we came up with was we designed using a very, very long flatbed lorry. It had a mechanized roller drive on it on the flat area of the bed, which then used to rotate the cable drum to unpay the cable into the excavation and under the ground. The great thing about it was that we could rock up with this cable drum where we needed to do the deployment, unreel the cable, whereas conventional means we had to get in a very huge big crane, as you can imagine, to lift one of these bits of kit. And to get a crane down a country lane is not a mean feat by any means. So this was a lot better way of delivering that. We also built and designed what we call a cable drum handler, which you can see in the lower photograph, and that lifts the cable drum off the lorry. And the cable is also deployed into the hole underground via a ramp, which we also designed. But another great example of bringing innovation in-house to solve an age-old problem. Other areas of the business where we get involved with, so we work with our colleagues at Hinkley Point C. So you might be aware Hinkley Point C is a brand new nuclear power station that is currently being built. Its location is it's basically Avon or Bristol area. It's on the Bristol Channel. Part of our remit with that project is we had to build undersea tunnels that are about 5 or 6 kilometres long. And in those tunnels, we had to send people to work. Because they're very, very long, the way they used to do it is using little buggies to transport people and the materials, which was fine. They would drive in, but when they got to the ends, the tunnels weren't very wide, so they couldn't turn the buggy round. So the only way out was to reverse all that long distance back along the same way they came in. The problem with that is sometimes the buggy would go up what we call the invert, the side of the tunnel, and it would flip the device over, which is not great. So we came up with a solution. So we adapted a conventional, what you call dumper truck with a cab on. But the unique thing and the innovative thing about this is the cab could actually swivel 180 degrees either way. So what that meant effectively was that the driver would drive in facing forwards. When they got to the end of the tunnel and they had to turn around, all he had to do was to turn the cab round 180 degrees and reverse out. But effectively, he wasn't reversing. He would be still driving forward because he turned his cab around 180 degrees. So that was quite an innovative bit of kit that we developed. We developed 10 of these and supplied them to the project, and they're still currently being run. And you can see from those photographs them running up and down the inside of the tunnels there. It's quite an interesting project. We fitted something called human form recognition cameras to them, which I'll come on to shortly, which basically detect the presence of human beings close to the machines. Just thought this would be a useful slide to share with you. So within engineering, within Balfour Beatty, we have a huge selection of CAD projects, computer-aided design. I'm sure you guys on this call know exactly what computer-aided design is, but it allows us to build up very complex designs using CAD packages, which then in turn we can produce real-life models, etc., from those. But a lot of the outputs from CAD are detailed engineering drawings, which allows us to build up the actual equipment and plants and equipment from those drawings. We also use computer-aided design to talk to our clients and our customers to give them a very high level or a concept of how we're going to approach a certain project. And you can see from those examples there, we've got many different types that we've done over the years to deliver that sort of capability. Also, touching on the subject of CAD, we've got 3D printing. For those of you who don't know what 3D printing is, it's basically you can build stuff, quite small stuff, but allows you to build stuff that is printed using layer after layer after layer. It takes a little while, but you can build real-time stuff that you can use to help you solve problems. And it's all done from the computer. The file is sent from the computer to the 3D printer, where it's built up over a period of time. And we've used this to our advantage. Again, traditionally, we use outside what we call fabrication companies to build and test products for us, which is fine, but it's expensive. But we found using 3D printing, we can try models and build them up, get them tested, take them to our customer to see if they like them. If they like them, then we can get the real one built up by an external fabrication company. So it allows us to save time. We can do it on site, and we can print them as and when needed. And it also allows us to talk to the customer to show them what the design is going to look like, and to provide them with the assurance that what we're going to produce for them it meets their criteria and their specification. So touched on this very briefly earlier. So human form recognition is a huge project within Balfour Beatty. Going back to where I said earlier that safety is our #1 priority across every work site, across every project we do at Balfour Beatty. And unfortunately, over the years, we found that people basically get too close to the machines when they're on site. This can happen for a whole host of reasons. Construction sites are traditionally very noisy. They can be dusty. They're quite difficult environments to operate in, and people sometimes just don't see the machines, even though these are huge excavators or dumpers or lorries. Sometimes, unfortunately, people are on the mobile phone or they're distracted and they don't realise they're getting really close to a machine. So what we've done is we've developed something called human form recognition camera systems. So we basically bolt 4 high definition built in with artificial intelligence to detect the presence of humans. And what happens is if a human gets too close within the detection zone, then an alarm goes off in the cab and the operator of that machine is notified and the machine stops instantly. The person who gets too close to it is also notified by an alarm on the outside of the machine, and the person then moves away to a safe working area where the machine can carry on. But what this gives us is it gives us now the ability to look at human behaviour and understand what makes people get too close. We get live video clips that come back from the human form recognition system which we can play back then at a later time. And using AI algorithms, we can understand what human behaviour is and what leads them going into those danger zones. And then we can change, it's an education piece, really, but we can change people's behaviour in time to stop them going into those danger zones. This is it's an ongoing initiative across Balfour Beatty, but it's a great example of where technology, up-to-date innovation is using to literally save people's lives. And we've mandated that on all our Balfour, or many of our Balfour Beatty machines across the industry. I guess most of you are tech savvy on this call, so you'll probably know what telematics are. But telematics in a nutshell, it allows us to monitor where our machines are. Just like you have on a car, you have a modern tracking system now on most modern cars. If they get stolen, you can look at the tracker to see where they are. Not only does it provide location information, but it tells you, like on your car, when it needs a maintenance, how much fuel is in there, how much fuel has been burned. We use exactly the same principle on many of our machines. and we use that as a real source of information to make informed decisions on. A lot of our machines, however, are quite old. And I say old, they could be up to like 10, 15 years old. In those days when they were built, telematics technology didn't exist to the same level it does now. So we've got a project underway where we're what we call retrofitting this telematics hardware onto the existing older bits of kit, which allows us then to allow us to track location, for example, how much fuel has been used, how often the engine has just been idling and it's not being used, all of which allows us to make informed decisions. All of this information comes into a platform, a telematics platform, which allows us to drill down, see exactly where each of our machines are, up and down the UK. So it's a really interesting project, and it makes us more aware in terms of our sustainability, our carbon footprint, and what we can do to sort of reduce idling and improve fuel consumption. So we've got an operational control hub where I am in Derby today. So the problem here is we've got all these machines reporting all this really useful information and all this data that we need to look at and make informed decisions on. But how on earth are we going to get all that information off all those machines onto screens that we can make sense of? So what we've got is 8 huge television screens, basically, that are all connected together. They're all powered by one computer, and all of the information goes into what we call a data lake, where it is serviced then from the data lake onto these 8 operational control hub screens that allows us to make those informed decisions that we talked about. And it also allows us to bring our customers in to show them their particular project sites where we've got our machines working, and it allows them to see firsthand and also in real time what the status of their project site is. For example, how many machines are at HS2, how many machines are operating, how many machines are idling, what's the average fuel consumption. So there's lots and lots of data coming back that we can now start to work with our clients and our customers to make a lot more sense with, and they can then go away and work and learn from that data. So it's a really interesting, really sort of area of the business that's expanding because there's so much data available now, and we can act on that data in many, many different ways. The next few slides, I wanted to talk to you really about carbon footprint and sustainability. Within Balfour Beatty and across the construction industry, there is a huge, huge drive to reduce our carbon footprint. As you can imagine, a lot of our machines have been diesel powered. They still are diesel powered. They consume a huge amount of power, a huge amount of diesel, none of which is sustainable. And in the modern age that we all live in, we have to do our bit for the planet, and Balfour Beatty are no different. So we have got a huge, huge drive across many of our project sites now to come up with alternative ways to power our machines. One such project is a project called Lower Thames Crossing Project. Balfour Beatty are building a tunnel that will go under the River Thames to ease up the congestion around the M25 in the London area. But our client has put a huge constraint on us in that we're not allowed to use diesel to power any of our machines on that Lower Thames Crossing project, which is a huge undertaking because traditionally the construction industry, as I say, uses diesel to power their machines and their equipment. So we had to come up with some innovative alternative solutions to diesel for the fuel. And we come up with several, one of which is called Syntec. Now, Syntec is an alternative to diesel, and it's actually made from an extract from McDonald's waste cooking oil, would you believe? You can't just put the cooking oil straight into the machine because it'll clog the engine up. It has to be treated, it has to go through a certain process. But the really interesting thing about it is that every time you go in and buy yourself a burger, some chips, whatever it might be, the byproduct, that waste oil, is coming into our machines, which we will then convert, blend with other alternatives, and we can then put them into our machines to burn, and it offers a lot lower emissions. And we're currently trialling that technology not only just Lower Thames project, but other projects as well. And the results that we're getting back are really, really encouraging. So we have to adapt the engines to work with the cooking oil, as I say, otherwise they wouldn't work at all. You can't just put raw cooking oil into an engine and expect it to work very well. It might cough and splutter a little bit, but through a refinement process, we can allow that to happen. We're also looking at electric powered machines as an alternative, just like you have EVs now for electric vehicles and cars up and down the UK. Then they're starting to become quite popular on construction sites. And I'll talk to you a little bit more about those in just a moment. Other alternatives is using hydrogen to create electricity. And that's an interesting concept. And also, of course, using solar power and wind turbines to enable off-grid charging of many of our EVs and electric machines. We often find ourselves on a construction site where there is no mains electricity. A lot of our construction sites are up in northern Scotland on the side of a mountain, and there's just simply no electricity there. So we have to innovate. We have to find alternative sources of fuel to provide us with power, which makes it interesting and challenging at times, but we do have ways and means. So hydrogen electricity, this is relatively new concept, but we're starting to see this come into many of our project sites now. So it's basically using hydrogen fuel to create electricity. And you can use it very, very precisely, and it allows us to generate power on a construction site, again, where there's perhaps not traditional mains electricity. It's very, very silent in operation. If you wander up to one of these, it is eerily quiet. There's no engine in there. There's no gas or exhaust fumes. It has zero emissions. And the quirk of it, the only byproduct of this chemical reaction, how it works, is water, because it splits hydrogen and water. So you're left with the water, and the hydrogen is converted to electricity through a chemical reaction. So it's a really, really interesting bit of technology, but one that we're using within the construction industry as an alternative to diesel means. The hydrogen is delivered to site on a huge, specially adapted lorry that's got an onboard tank that delivers the hydrogen at quite high pressures into the generator fuel tank. And as I say, you can use it on sites where conventional mains electricity just isn't available. There is a disadvantage, unfortunately. Hydrogen tends to be quite expensive. At the moment, it's typically around double the cost of diesel, like for like comparison. Like a lot of new technologies, the more it becomes adaptive, the more it's likely to drop and that volume cost, and it will hopefully align closer to what the traditional diesel costs are. But it's an interesting bit of technology, and one that we're adopting across many work sites at Balfour Beatty as we speak. Talked on earlier about electric powered machines and plants. So this is another big area where we're seeing quite a huge expansion of electric machines. Again, rather than have dirty diesel engines powering these, you take out the diesel engine and you fit it with an electric motor or a number of electric motors and a huge battery to power the machine. Similar to an electric vehicle that you see on the road, it does need to be recharged. Most of these tend to get charged on site overnight whilst we're not working. Just like you charge your car at home, you plug it into your socket, don't you? Your wall socket, and leave it on charge overnight. You get in it the next morning and it's 100% charged. Principle's exactly the same. What we do in Balfour Beatty, it's a lot bigger scale, and I'll talk to you a little bit more about that in a moment. The great thing about electric plant is it's very, very quiet. It's eerily quiet. It's not sending out huge dirty emissions of black smoke that you get from traditional diesel engines. There are hardly any emissions associated with electric plants. So it really, really is really good for CO2 emissions and our carbon footprint. Again, the disadvantage is it tends to be quite expensive. These machines, because they're relatively new, they're still being introduced into the construction industry. They do come with quite a high price tag. But as with hydrogen, I expect in time for the cost to come tumbling down once they become more and more available. But great examples there. On the right, you can see a big excavator. and on the left we've got what you call an articulated dumper truck. They're just two examples of typical items of plant and machinery that we see on our site now that are operated by electrical means. This slide, I thought I'd just show you some typical charging elements that we need. Bit like your car charger at home, but just by a magnitude a lot bigger. So typically, the output voltage range, for those of you that are technically savvy on the call, but are between 200 and 920 volts DC. So they're quite high voltage. In terms of power, you can talk anything between 50,000 watts up to 600,000 watts. So these are big items of power that we need to deliver into the lithium-ion batteries. To give you some sense of perspective, you take your standard mobile phone, the power required to charge that is typically around 5 watts. So it gives you an idea, that sense of magnitude in terms of how big this bit of kit or these items of kit are. But you can see various examples on that slide of the typical plant and equipment that we use that's deployed onto site to charge our electric plant and equipment. This slide just gives you a bit more of an overview in terms of generators, on-site generators, electric plant, and what we can do in terms of towing electric plant to site, towing generators to site, and how we deploy them. Really, lots of electric vehicles, lots of hydrogen, and lots of EVs around. This slide just gives you an idea in terms of where we're going with the big, large-scale items of plant. These are huge articulated dumpers. If those of you that have been up and down motorways, you'll see them by the sides of motorways on construction sites. Traditionally, they were always powered by diesel fuel. We're moving away from that now. So these are brand new Volvo articulated electric dumper trucks. So if you look at some of the numbers in there, the battery capacity, 245 kilowatt hours. That's a huge battery. Machine's payload is 29 tons. That's 29,000 kilograms. So these are big items of kit. Maximum charging power, 350,000 watts. So that's why we need the big charging infrastructure, these big charging machines to plug into these bits of kit and charge them up. But really exciting times. This is the future of where construction sites are heading. It's going to be all electric. It's going to be hydrogen powered. It's going to be wind turbine powered, as this slide shows. So again, on sites where we don't have mains electricity, we have to innovate. We have to come up with alternative ways of providing the power for the site cabins that are there, for the machines there. So we deploy temporary wind turbines, which you see up and down the countryside now. There's lots and lots of them, but they're great. These are relatively small, easily to deploy, and they can provide reasonable amounts of power throughout the year. So very good, very clean, low carbon footprint, obviously, and some great savings around traditional fuel usage that you'd use through diesel. And that is the end of my slides. Thank you very much for your attention.
No, it's fantastic, Mark. Thank you so much for sharing all that innovative information and sustainable information around the construction industry. We really appreciate it. Thanks, Mark. Thanks for your time, and take care, everyone. Have a great afternoon.
You're very welcome.